In this video, we're going to be looking at solving quadratics in Vertex Form for an exact answer. And for those of you who are wondering, well, what does an exact answer mean? Well, it means that our answer is going to have a radical in it, and we're not going to have any decimals in it. Now, let's go ahead and take a look at how we can approach this problem. Notice that once again, this is in Vertex Form, and when I say Vertex Form, it is in the form of f of x is simply equal to a times x minus h squared plus k, and that is our vertex form. And so notice that's what this is over here on the left. And if you notice, right, we already have it set equal to 0, so we are going to go ahead and jump right into the process of moving some things around. But because we have an a value of 2, and we also have this negative 26 over here for our k value, right, while our 2 is our h value, there's actually a lot of work that we got to do. And it's not going to be as simple as some of the other ones where we didn't have that a value. So that's going to create an extra step, but I'm going to show you exactly what that looks like. The main thing that you want to do is first we want to start by moving our constant over to the right side. So I'm going to go ahead and write that right here. First, move constant right. And so I'm going to do that. I'm going to go ahead and just draw a line here through my equal sign, because we always want to keep our equation balanced. And this is subtracting 26, so to move it to the right, I want to do the inverse operation, which is adding 26. So I'm going to do that right quick. Now notice on the left, we now have left over 2 times 3x plus 2 squared. And on the right side, we have 26. Now keep in mind that once we get to this point, notice that this 2 is being multiplied to this 3x squared. So what I want to do is I want to get rid of a first. So I'm going to go ahead and put second, move a right. So in order to get rid of this 2, it's being multiplied to 3x plus 2 squared. So I'm going to do the inverse operation of multiplying, which is dividing. So I'm going to go ahead and divide by 2. And I'm going to do that on both sides, because remember, we do have to keep this balanced. Now on the left, it makes it really easy, right? Because 2 divided by 2 is just 1. And that simply leaves us with now 3x plus 2 squared. And over here on the right, if we divide 26 by 2, it's going to give us 13. I'm going to go ahead and extend this equal sign, so we're closer to being done. Now for this next step, we can't do anything to what's on the inside of the parentheses until we get rid of this squared. So third, we're going to go ahead and we're going to take the square root of both sides. So I'm going to write square root both sides. So I'm going to take a square root of this left side and take a square root of the right side. Now do keep in mind, when we take the square root of the right side, we know we're dealing with a quadratic and we're likely going to have 2 different solutions. We want to go ahead and we want to put our plus and minus there. Now on this left side, I'm going to cross out the 2, because remember, anytime we take the square root of something that's being squared, it eliminates the square. Move this up just a little bit. So all we're left with right here now is 3x plus 2, and that's going to be equal to plus or minus the square root of 13. Now before we do anything else, I do want you to know that we have a 3 that's in front of our x. That was another thing that was different about this particular problem. And because we have that 3 in front of the x, and we want to isolate x and get it by itself, we're eventually going to have to divide that out. But before we divide it out, I first want to move my constant away. So I have a positive 2 on this side. So to move my constant to the right, I'm going to subtract it. So I'm going to go ahead and just write here, fourth, move constant right. So I'm going to do that by inverse operations. We're going to subtract 2 from both sides. It cancels on the left, leaving me with just 3x Hopefully to you at this point it's starting to look a little bit simpler. Now we do have to combine these terms, but notice this is a radical and this is just a regular constant value. So what I like to do is I like to put the constant up in front. So I'm going to put negative 2 plus or minus the square root of 13. Now if you were to put that term behind the 13, in other words, if you would have had plus or minus square root of 13 minus 2, it works as well. But I always like to bring that number up in the front. That's just my preference. Now I'm almost done, but we don't want 3 x's. We just want a single x. So we got to get rid of this coefficient of 3. So we have another step. I'm going to put fifth. Divide coefficient of x to isolate. So I'm going to go ahead and go over here, and I want to divide this coefficient of x out, that 3 there. So I'm going to divide by 3. And notice if I divide on the left side, I got to divide on the right side. Now 3 going to 3 one time, and that just simply leaves me with a single x. And so what we end up with is we have x is equal to negative 2 plus or minus the square root of 13 over 3. So it's the same thing we had up here, but now we got this broken down. Now notice I always like to break this up into a positive and a negative solution, right? When I say positive and negative, I mean in the sense of we're adding a radical in one and we're subtracting it in another, right? So I'm gonna divide this up into 2 different solutions. I'm going to go ahead and write one over here, and I'm going to put my little plus sign, right? That's going to be the one where we're going to be adding the radical. And then over here on the right, we're going to have one where we're subtracting the radical, doing that subtraction sign right there. I do want you to keep in mind at this point, it also is very important to check and see, can the fraction simplify? So I'm going to put right here, 6th simplify fraction. Now when I say simplify, I'm specifically talking about this negative 2 and the 3 that's dividing into it. Sometimes you'll run into a situation where these can be simplified and they'll just turn into a whole number or an integer. Sometimes it'll just simplify and reduce. And let me give you an example of what I mean by that. If I were to take my calculator right quick and I were to go ahead and let me go back to calculate, I'm going to hit alpha y equals enter. If I were to put my fraction in, negative 2, right, and it's being divided by 3, so over 3, and I hit enter, notice it stays exactly the same. So that tells me that this clearly can't be simplified. This fraction is in its simplest terms. But let's say we had a different number. Let's say we had, just to give you an example, let's say it was negative 4 over 6. Well, you wouldn't want to leave that as your answer, because when I hit enter, notice negative 4 over 6 changes it to negative 2 over 3. So if you're not good at being able to recognize whether a fraction can be simplified or not, go ahead and use your alpha y equals function on your calculator and check it to see if it can be simplified before moving on. Vice versa, let's say I had something like 8 over negative 2. If you were to leave your answer like this with a radical after it, it would be wrong, because this can be simplified to simply an integer of negative 4. So again, I can't express how important it is to always see, can this be simplified? Now, in this case, it can't, so we're going to go ahead and rewrite these as our final answer. I'm going to write my first solution as simply negative 2, and I'm going to start with the addition first. So plus the square root of 13, and it's going to be over 3. This is one answer. I'm going to go ahead and do my next one, right? This one, the only difference is we're going to be subtracting instead of adding. So I'm going to go ahead and do negative 2. And now we're going to do the minus the square root of 13 over 3. And we call this an exact answer. Notice there's no decimals in it, right? We just have integers and radicals. Now what I would tell you is you can still check this with the calculator very easily, but in order to check it with the calculator, we do need to know what the decimal value for each one of these is. So in other words, I'm just going to write the approximate value, and I'll do a little rounding and just see what it's equal to. But if it were me and the teacher said to leave it as an exact answer, which is very common in college and very common in high school, leave it just as it is. But now let's go ahead and see what it actually equals. Let's convert it to a decimal real quick. So I'm going to go ahead and go in my calculator, and I'm going to hit alpha y equals to get my fraction bar, and I'm going to type in -2. I'm going to start with this plus the square root of 13, and then I'm going to go to my denominator and put 3. And when I hit enter, notice it gives me this decimal strand, 0.53518 and so on. But I'm just going to put 0.53. I'm not even going to round. It's kind of like just getting what we call a ballpark figure. All right, I just want to know just about approximately what is the value. And I'm going to go ahead and do this one on the right. Now, because I don't have to enter the whole thing again, I'm just simply going to click up and highlight it, hit enter, go to the numerator, and I'm going to change that positive sign to a subtraction sign and hit enter. And notice this one tells me that it's -1.868517092. However, I'm just going to go ahead and ballpark it again and say -1.86. I'm not even going to worry about rounding. And then I'm going to use these two numbers just to confirm, using my calculator, that I did do the work properly, right? Because maybe I made a mistake. So I'm going to go back up. When I use the calculator to check this, I'm actually going to put in what we started with, right? This quadratic that was in Vertex Form. So I'm going to go ahead and I'm going to hit y equals so we can graph it, and I'm going to type it in real quick. So we have 2 parentheses 3x plus 2 close parenthesis squared minus 26. All right, now that I got this in, I'm going to hit graph. And you can see the parabolas right there. And it looks, I feel like, roughly just looking at the image, it looks like I did it right because they're in pretty close proximity to where I would think 0.53 would be on this right-hand side and -1.86. But I'm going to go ahead and verify it by using my trace and my second key. So I'm going to hit second trace. And then I'm going to go down to my 0 function in my calculator, hit enter, and I'm going to start with this left one. So I'm looking for my cursor, and there it is. It's to the left of the 0. Hit enter. Click to the right where it goes below it. Hit enter again, and notice it tells me that it's -1.868. And that's what we have right here, -1.86. So I see this and I go, you know what? I did it right. That one is correct. So now we're going to check the next one. I'll hit clear, hit second trace again, go to 0, hit enter, and I'm going to go to this right-hand side, go to the left of my 0, which is a little bit below it, hit enter, click to the right, hit enter, and notice it says 0.5351838. And notice I had 0.53. So I can go and check that off as well and go, you know what? I did it by hand and I solved it and got exact answers, but then I went ahead and used the calculator to confirm that my zeros were correct. I can't emphasize how important it is to know how to do this by hand, so please continue, even if you know the calculator trick to check it, use that to check your work. But solve it by hand to make sure that you have those foundational algebra skills that you need.